This is the reflected frequency, correct? F0 plus FD if vehicle is coming towards to you. If vehicle is going away, it will be F0 minus this. This is 1000 hertz. Means if the shift is, if vehicle is going 50 kilometer, if the delta F, FD equal to 200, this will be 800 hertz. That means vehicle is moving away from you. Moving is coming to you, it will be 1200 hertz. I'm giving, correct? The Doppler shift depends upon that. Already we know the equation. This equation gives very clear. What is the Doppler shift frequency? That means the vehicle velocity. The vehicle which is moving in front of velocity and the frequency you are transmitting. This is the delta F or FD. Okay, so we can know that this is going away, correct? This is vehicle coming towards you. This formulas note down. That's what important. You can expect simple problem how it works. Now, another thing I told you that when we talk about radar, the F0 is called a transmission frequency. Correct? Sometimes they call center frequency. Center frequency, transmission frequency, all are same. That's what the FC. Sometimes they put a FC, center frequency, F0 output frequency, or FT, transmission frequency. Correct? So all these things, there's nothing but that. That's what the Doppler radar transmit transmission signal. That is fixed frequency. That will be decided by the manufacturer. Radar manufacturer decides. Right? So radar, when you want to design, depending upon what is the frequency it is transmitting, F0, transmission frequency. Right? Based on that, the radars are classified as S-band radar, X-band, X1 band, X2 band, X3 band, Q band, K1, K2, and Ka band. In worldwide, whether it is used for military purpose or autonomous, wherever you see a radar in fighter plane, that will be any one of the type. They say S-band radar, correct? Say X1 band, X2 band, X3 band, Q band, KU, K1 band, K2, Ka band. These are named internationally accepted. You cannot change it. Okay? If that is the, when your radar will be called as the S-band radar, if its F0 or transmission frequency is 2.455 gigahertz. Please know this single number. You are going to science means only on single frequency. If it is 2.455 gigahertz, that is nothing but 10 power 6 hertz. Then that radar will be called S-band radar. Instead of that, if you use 9.14 gigahertz, it is called X1 band. Similarly, 9.9 X2 band, X3 band. Right? So based on the frequency what you are going to transmit, then the band that is called as this one. Okay, that is one thing. Next thing is, now if I am using S-band radar, okay, its center frequency is this. Now we know that that is F0. What is the FD? FD, already you know the formula. This formula, 2 into V divided by F0 divided by C. Correct? Now, if I use this F0 is 2.45 gigahertz, right? What will be the FD? FD will be change in 4.53 hertz. Please see that. What is this one? If vehicle speed is 1 kilometer, your radar is fixed. Your vehicle is not moving. You are transmitting this frequency towards the vehicle coming from in front of you or going away you. Now, if the speed of the vehicle which is moving in front of you is 1 kilometer, what you will get is 4.53 hertz. That is the change. But what is this frequency? I am talking gigahertz. F0, if you write fully, 2455, correct? 00000. So many hertz. Correct? 2.45 gigahertz. That is into 10 power 9. So this is the actual frequency in hertz. Now, if vehicle in front of you is moving towards going away by 1 kilometer speed, your radar is not moving. Right? In that case, what will be delta F? Delta F or FD will be 4.53 hertz. What is FT? Actually, this is change, but actually, what you're going to FT? FT is nothing but 2.455. Sorry, point is not that. 24550000453 hertz. You see that last single digit decimal point only is changing. That's what change in frequency, received frequency when vehicle in front. Now, if a vehicle is, you are using K-band, your vehicle is 100 kilometer speed coming towards going here. What will be this one? FD will be 4.53 multiplied by 100. So, it will be 453 hertz. This is delta F. This should be added with this big number. That's all the change you will see. Right? So, now that you understand what is important of transmission frequency. Now, if I use S band, its frequency is this much. Change in frequency, received frequency only 4.3. That is very, very small. Correct? Vehicle is traveling by 0.1 kilometer speed. What will the signal change will be? 0.453 hertz. Correct? Compared to 9-digit number in that just so we say that the resolution of detection will be very bad. Correct? For a 1 kilometer, if the delta F or FD, this is nothing but FD or delta F. That is what this column represents. Is bigger is always better. Per kilometer, then which is better in this? This is the Ka-band radar is better. Why? If vehicle change speed is change of 1 kilometer, you will get 60 up to 66 hertz. Here it is only 4.53 hertz. So this radar is better. Ka-band radar is better for higher deduction, velocity deduction, correct? Resolution. If vehicle speed of 0.1, 0 to 0.1, this one, you will get 6.1 hertz change. Here it is 0.453 hertz. So this is easy to do. Bigger the number, delta F, it is better. So Ka-band. But this, which band you can use is decided by FCC in US. Internationally, it is controlled. Federal Communication Committee, FCC. It is an American, this one. They control worldwide. Whatever they, like ISO, FCC controlled, what is frequency your cell phone tower should use. For example, no, cell phone, not this one. For a BSNL, correct? Or Vodafone, or Airtel, Zio. This, you say spectrum you are talking, no? The spectrum itself, first what should be used for cell phone is decided by FCC only. It is American, but international accept. Then finally it comes to ISO, correct? International Standard Organization. FCC, the federal. In India, the government of India, correct? Our broadcast ministry decides. That's why they're selling spectrum, selling for cell phone, no? 1 lakh, this on this spectrum. That is spectrum in that what frequency you can use for cell phone. Similar to this band, for cell phone also there's a frequency. What frequency they can transmit each cell phone. Good. Geo use one particular frequency. BSNL use another frequency. Same frequency cannot be used like this spectrum. That is decided by FCC worldwide. But when it comes to India implementation, that particular country broadcasting government decides. In India, broadcasting ministry decides. So we can see that this is how it used. But which one to use, that is already is fixed. For autonomous vehicle, for example, Bosch is making, some XYZ company is making the radar. It may be S band or X band or Q band, K band, Ka-band. That already fixed. But you have to see that. Okay. So better is higher. This higher the transmission frequency. If not, higher will be the resolution of the received signal. That is delta F change. That means even small change in speed can be detected in this compared to this. Okay, that's what. So here same thing is given. How many hertz will change in miles per hour, knots? Because you know that fighter plane, all those things they talk not in kilometer mile, they talk in knots. Ship, all those things. So that's why these are knots. How 1 knot speed changes, how much with the frequency change? We know 1 knot is 2.3 or 4 kilometer, if I'm correct. Mile is 1.6, correct? Like that. Nautical the knots is around 2.3 exact. I don't remember. Maybe somebody from Navy, correct? A merchant vehicle, somebody is there, I think they can tell. Fine. So that, but basically this is what it is. This is given for other things also, miles per hour, knots per hour. Correct? If the vehicle speed changes, so that's what it is shown here. Okay. So you understand, higher the broadcasting frequency, better will be resolution of detection, velocity detection. Minimum speed what to change, 50 to 50.1 can be easily detected here compared to this radar. Because per kilometer 61 hertz is changing. It is better. Please see that even this is not big. Correct? 33 into 10 power, 33 point into 10 power 6, sorry, 10 power 9 hertz. Correct? 33, correct? Followed by 4, followed by 8 zeros. That is the F naught. You are adding 63. Last digit you are adding after 10 digit you are adding per speed change. But that is a big number. That's what we'll check. The electronic circuit can detect. That's what the electronic beauty of the electronics. Even 0.1 hertz change out of gigahertz also circuit can detect. Radar circuit can detect. Okay. Next thing is, already we talked radar range and power and range. We are talking here, it is a pulse radar. Correct? So we are talked about this is continuous radar. Correct? Which you use for measuring with the Doppler shift or continuous radar. It's a block diagonal, you know, but you use a 2 antenna, one for transmitting, because this will be transmitting continuously. It is going to receive continuously. It will receive continuously only when the object is front. Otherwise, receiving signal will not. No object in front, it will not receive. Within the radar range, if there's no object, this signal will not come. Whether it is a pulse radar or continuous, signal will not come. Here we will transmit a pulse, return pulse may not come if no object is there. Here going to transmit continuous, return signal may not come. That's what I just wanted to say.
Sir, one doubt, sir.
Yeah.
Sir, like if it is continuously transmitting, one is continuously transmitting, one is continuously receiving.
Yeah.
So how will it detect the range? Like every pulse, it is like same
not
only.
Pulse. Correct? Yes, the change in frequency is going to measure change in the frequency. Delta F. You are finding delta F.
Okay, sir. So we are finding the change in the frequency. So one if it is like if some object is found in place of that, it will receive the signal.
Yeah. So see, for example, I told you 1 minute.
Yes, sir.
I am transmitting 1000 hertz for understanding purpose. This is what transmitting sine wave.
Okay, sir.
Right? Now there's an object here. Right? Somebody is standing. It is the same thing only. Reflected.
Okay.
Now, if object is coming towards, he is moving, this man is moving towards your radar. What will happen? The frequency will become 1010 hertz for understanding purpose. Say he is traveling, say 10 kilometer speed. This one is walking towards you.
Okay,
it is reflected. So delta F is nothing but reflected frequency. Ft minus F naught is Fd. That's what the circuit is going to do. So it will get 1110 minus 1000. We get 10 hertz. What the 10 hertz comes to the discriminator. Discriminator already know 10 hertz means it is 10 kilometer. It plays. Instead of that, if this person is watching 20 kilometer hour moving towards you, what will be the frequency? 1020, for example. So delta F will be 20 hertz. So the discriminator already knows that 20 hertz means the fellow is traveling 20 kilometer speed. That's what it's going to display.
Okay, sir.
Okay. Fine.
So it means what I understood is like continuously it will be monitoring, and every fraction of second it will monitor the distance. Based on that, it will find out the relative
velocity.
velocity.
It will be displaying continuously. Maybe sometimes they may not do every nanosecond. They may do every millisecond, updating every millisecond. But signal is coming continuously. If you are, the radar can continue display. This is meaningless. If it is changing small display will be getting bored, no? If it is flickering, the value will be flickering. Correct? So it may do, it is coming continuously, but the display, this will be display every millisecond, every second once. That is sufficient because the speed will not change much, no? 100 kilometer, if you update 1 millisecond after, the vehicle would have moved only few half meter something. The radar cannot even detect. That much small. Okay?
Understood.
Okay.
Thank you, sir.
Okay, fine. So now that we know, now we are talking, if I want to complete this today, we know that the radar power, because the pulse radar, this is the during which it is sending a pulse. I told you the radar, even pulse radar can send a bunch of pulses, or it can send a square pulse. Both. Correct? This is transmit pulse. This is also transmit. Here it is sine wave, here only a square. That's what is showing here. I just wanted to understand what is the average power, this one. If this is on time, you see that this is 0 volts, correct? Then this is plus 100 volts, for example. So for this much duration, the transmitter is sending a pulse. Then there's no pulse. Again, there's a pulse. This is called on time, correct? During which I'm talking pulse radar. This is called on time. This is called as off time. On time, T off. Okay. So duty cycle. Correct. So here I have different on time. Please see that the frequency is same. This duration, total time, both are equal. Please see here, both are equal. In one, the on time is very small, off time is bigger. Here, the on time is big, the off time is very small. Correct? Off time is very small. So here, please see that the power transmitted, peak power transmitted is higher here. Correct? So you are sending for large amount of time. Total power transmitted is big. Here, total power transmitted is very small. So the average power, when you see that, the pulse width, this is pulse width. This is a pulse width, PW. This is duration. Correct? So this is a pulse repetition frequency, this time. Number of this one. So then you will say P average, P peak. This is peak power. This is average power. So average power is calculated for entire duration. Area under this curve, entire curve is average. Which will be bigger? This will be P average will be bigger because large on time, very small time. Correct? So the duty cycle is decided by P average by P peak. That varies depending on how long you are transmitting and how long there's no power is transmitted in pulse radar. For this, you need more cooling. What is the advantage? If you are transmitting more power,
more range will be higher.
R will be both. This will R will be more compared to R will be small. Okay. So more range can be deducted, but please neither when average power is high. See average power here, your circuit, everything will get heated up. You have to cooling water, all the cooling system also needed. But if you want a more range, you will go for this one. This how it will go. Okay. Then we saw two types, other continuous Doppler, and apart from that, there are a radar which combines both. Correct? So this is continuous wave radar, which can measure only velocity. You can see that you are continuously transmitting a waveform, and the received waveform, that this is velocity measurement only. Pulse radar sends a small pulse and receives the pulse and calculates the time, this one, range. Correct? Range is nothing but total time multiplied by C divided by 2 is the distance. Correct? Here R is nothing but range. Correct? T is the time. This is what if you rewrite, you can get it like this, nothing more. The same formula is written here. Right? So let me clear it. You can see here R is range. Right? R equal to range equal to C multiplied by capital T. That is here it is put a small t. Both are same. T is time divided by 2 is the range. That's what written. What is the time taken? You can calculate. So this can find only distance generally. Then there are another type of radar we call pulse Doppler radar. I want to find the velocity, also the range together. So what I do is I will show this figure. So this is continuous wave radar. Correct? Doppler radar is going to transmit this kind of this, then receive frequency. This is called pulse Doppler radar plus Doppler radar. What it does, that's what initially started. Actual pulse radar will be sending square pulses only. Initially developed Yeah, like this. This is pulse radar. Correct? It sends pulse only, square pulses, on-off pulses, but duration is varying. This is meant for range, distance measurement. Correct? And already we saw this is for velocity measurement. I want velocity also with single radar. Correct? So what they developed is what we call pulsed Doppler radar, in which actually there's a pulse. Instead of pulse, I said a burst of pulse at the frequency. Correct? For short duration. Correct? And next nothing is there. Again, I will send one more burst. This is what I am transmitting. Correct? This is what I am transmitting. Now, this is received. This is one cycle, first cycle. Please see that I am transmitting a sinusoidal waveform of, for example, 1000 hertz for 1 microsecond. Now, this went and hit and came back. This is reflector. This is received signal. Again, it will be sinusoidal and same frequency, same this one. Now, I know the capital T. So, I can find distance D equal to T divided by 2 multiplied by C. This is one thing. But one thing of beauty is, if I transmit a sinusoidal burst, the frequency 1000, if the vehicle is coming towards to you, what will happen? The received signal will not be 1000 hertz. It will be 1010 hertz. So I can find delta F. I will find T and also delta F. Because this frequency transmitted 1000 hertz, received is 1010 hertz, because vehicle is moving towards you at 10 km speed. So using this, I find the distance. Using this,